So welcome to this video presentation of dental metrology in this case. And for this demonstration we're going to focus on some key aspects not covered in some of the previous videos. In this case we've got some partially measured data. You can see some missing data here on this tooth. So we're going to look at interpolating data. We're going to look at calculating roughness values on complex freeform surfaces, and not just the 2D parameters which we've done in previous video presentations. In this example we're going to look at the 3D parameters. So some relatively new advanced work for people who've been following these video presentations. So let's start off by looking at the image. Just rotate that a bit. So this is a human molar tooth which we've measured in a XYris 2020 H instrument, and the H is standing for high gauge range, high angular tolerance, and you can see a pretty impressive measurement here of the tooth. So you can see this complex, obviously a complex freeform shape. We know what this is, it's a human tooth, so you intuitively know the dimensions of this approximately. But if you just look at the color scale here, this is it's just the upper part of the surface, and the gauge range of the sensor used was actually 3.3 millimeters max, so this range here is 3.2 millimeters, so most of the gauge range is being used in this particular measurement. Some loss of data, and we'll maybe see why that is in a second. This one here is just because it's out of range. We weren't actually too bothered about the lower sections here. We're very interested in this section here, as you'll see from the photographs I'm just going to show you. So let's start by taking a quick look at the surface, what we have, and here it is. So just a microscope view of a human tooth, just mounted in some plastic surrounding some plastic around here. If you look at the features of this, quite obviously it's difficult to know the dimensions of this from this photographic image. It's a 2D image, but we know this is a high point and we know this is a high point, and just below this upper high point you see a dimple here, a little feature which is quite dark, and that's the missing data in the XYris instrument measurement. Quite a sharp crack, well not a crack, a sort of crevice almost right in the center of this tooth here, and this lower region is where we've undertaken the wear study. And actually this particular photograph was after the wear study had taken place, and what we did here is we applied in a 1.5 millimeter diameter section, we applied some citric acid, some diluted citric acid, corresponding to the strength of something like orange juice or any acidic drink. And you can see the effect that's had. The test was for 1 hour. The diluted citric acid was not agitated, it was just sat upon the tooth. And you can see it's basically whitened the surface here. But if we just go to the right, that's the close-up. Here you can see that in more detail. Again, because it's a photographic image, we can't really see the dimensional characteristics of this, but we can see the whitening effect around this region. Well, let's go back to the measurement. As I said, a pretty impressive measurement. Many of our competitors would actually not present raw data, which is unfortunate. TaiCaan Technologies is very particular about only presenting data that's been measured. So we will never present data unless you as the user have interpolated the data yourself. That's what we're just going to do. So we have some missing data. It's not particularly important. We're actually interested in this region, but I'm just going to show you the function of how we would interpolate the data here. So let's go to edit the data. We have some bad data, some missing, it's basically missing data from the measurement. Let's go to the right, and if we just hit interpolate, what that's going to do is it's going to look at the missing data, the bad data, and then look at the surrounding values and interpolate the values that would be expected to be in the bad range. And you can see here this is highlighted in grey. It's done it for the outer regions here, which we weren't at all interested in, and it's presented in grey. That's not fixated until you, the user, coming back to here, if you have to decide that you want to do this. So I'm going to do that now. I'm going to fixate the bad data, and now you can see the data here has been filled in on this upper part where there was a very steep slope, and in the lower part here. As I said, we don't do this as a matter of course. We would always present raw data and then let the user use BEX, the software tool we're demonstrating here, to then manipulate the data should you want to improve the image in some way. Right, so we're interested in this region, the slower region, where you can see a feature which is, it's like a three-sided pyramid here, with the white light reflecting from the high point here, and some pretty steep sides on this. This particular measurement, just looking at the information panel on the left, the measurement area, you can see from the name of the file is 8mm by 8, 401 data, giving a grid spacing of 20 microns. Now for a roughness study, if we're interested in the change in the roughness of the surface, the 20 micron grid spacing in this image is not going to give us sufficient resolution to determine roughness changes with any degree of accuracy. So what we need to do is we need to take this measurement and then re-measure it and just focus on the lower region here. So we're going to do another measurement here just on this lower region. We're going to reduce the grid spacing size, and that's already loaded in. This is before we did the test, and here you can see the surface. I've drawn some contours on this, and these are spaced at 50 per millimeter, and I think what you can see, although this is quite a dark shaded surface here because of the lighting, quite a bit of roughness on this upper peak. Another feature that which you use here, we have additional lighting here, which is just a simple toggle switch, and that just changes the lighting effect on the surface. So you can use that. It doesn't change any of the data. It's just for imaging and for presentation purposes. And actually there are much more options around this, but that's in the toolbox and the options here, which I'm not going to demonstrate here. So I've just turned the lighting on just to give a slightly a higher intensity image of the surface before we've applied the citric acid to this. So my question is, how do I measure the roughness of this? How do I determine the roughness of this surface from this very complex shape? Well, as with other examples that we've seen, the first thing we should do is actually fit something to the underlying form of the surface, and the standard way of doing that, of course, is to use a Gaussian filter. So let's go to the filter, and it's in edit the data. There's filters here. These are three-dimensional filters. There's a median filter for smoothing data, and then you've got the Gaussian filter, which has the effect, let's bring that to the screen, as with the 2D cross-sections, of applying a Gaussian filter to the surface. And for this sample, we're going to do it for both the before and the after measurement. We're going to use an 80 micron filter. So there's the 80 micron. Let's click this, and let's see the effect that has on the surface. And I'm going to switch that to a top-down view, and here's the top-down view. Pretty difficult to ascertain any features on this because of the coloration, but this is now nominally a flat surface. Let's just check that in the cross-section. Here it is, nominally flat. We've applied the Gaussian filter to the whole of the surface, and if we just want to see a bit more detail, we can then, as we've done before, we can just adjust the color scales here to try to bring some features out. As I said, this is not changing the data, this is just changing the color scale so that we can find a central region. And here, and so here, bringing this in a very narrow range here, just here, like so. I think you can see the peak of the three-sided pyramid is here, with one leg going here, and one here. So what we're going to do for the assay calculation, before we've applied the citric acid, is just to select a region around here of 1.5 millimeters diameter. Well, how do we do that? Well, as we've seen before, we just use a brush. Here's the brush. We need to adjust the size of the brush. So let's go to the brush size. This is a radius here, so let's put 0.75, which is 1.5 millimeters diameter, and click that, and here you have the region. And I'm just going to apply this region around the peak, and I've got the crosshair on the peak, so let's just remove that data. Well, actually, for the SA calculation, we need the inverse of this image. We need just this central region. So let's turn the brush off. Let's go back to the options here, and let's invert the selection. And there I've inverted the selection. So now we have a 1.5 millimeter diameter region around the crown of this molar tooth, and if I now go to 3D form, I'm going to calculate the SA value relative to the mean height. So let's apply the mean height, and here you can see the calculation for the S parameters. So let's just hold this one. This is 2.04 microns SA. Let's leave this one fixed. Now let's go and do the same thing to the measurement of the same surface after we've applied the citric acid, the diluted citric acid. And I think you can see straight away what's happened here. You can see a smoothing effect, very evident with the contours we've selected here. I've still got the light on here. Turn the light off. You can still see the effect of this. So the central region that's been exposed to the citric acid has been smoothed by the action of the interaction between the diluted citric acid and the enamel of the tooth. And then outside of that region, you've got some roughness, which was already there before we did the measurement. So we'll apply the same process. Let's do the same thing. So we'll start off with the Gaussian filter. Edit, filter, Gaussian. Let's change the value here to the value we used in the last one, which was 80 microns. Let's put it in the top-down view. While that's processing, here it is. Let's change the view. Just let it finish to the top-down view, and let's zoom in a bit. Just make it bigger. With this coloration, with the color scale as shown, as before, this has now nominally been leveled. And actually you can see from just straight away from this cross-section the effect this has had, where the central region here has been smoothed quite dramatically by the presence of the citric acid. Well, we're doing this in 3D, so let's hide that. As we did before, let's adjust the color scale, and let's see what we get just by adjusting this. Let's bring this up just here. So that's quite blue. Oh, you can see that already just there. There's something. Let's bring this down. And I think here you can start to see the effect. And I think quite clearly, let's just change that a bit. You can see here, actually you can almost see the circle. And here's the region that the crosshair is following at the moment. Let's do as we did before. Let's ignore all these outer regions because we're not interested in those. We're only interested in the central region. Let's select the brush size to be 1.5 millimeters diameter. Here it is. And if we put that over here, and lo and behold, the 1.5 is almost exactly corresponding to the shape, where there's a change in the visual change in the surface, and that's the region I've highlighted here. And in fact, you can see the peak here. You can see this would be the peak of the pyramid structure with the three sides going up to the left, to the right, to the left, and down to the left here. So let's put that in the center. You can see actually it's a bit off center, so I'm having to bring it down here, which is now corresponding to the outer regions, which you can see quite clearly from this image. Same process as before. So right click, invert, mean Z, apply, and here you can see the change in the roughness. So this now concludes our presentation. We're showing here that the roughness is now 0.839 in SA. Just flick back, 2 microns before. So I hope you've enjoyed that study of dental metrology.